So good morning and afternoon to everyone, and welcome to the live demo webinar focusing on how to automate your workflows on the Opentrons Flex. My name is Fran Slater. This was supposed to be a Nick and Nick show, but unfortunately Nick couldn't make it, so you have me instead. But I am joined with one of my colleagues, Nick Rizzo, our product specialist. So today we'll show you the Opentrons Flex, and we'll talk through some key features such as the pipettes, the modules. We'll talk about a new hardware accessory that we have up here and some new software functionality. And then Nick will take you through a demo automating a workflow on the Flex using a protocol downloaded from the Opentrons protocol library. This is a very easy process to get existing protocols, some of which have been verified by our scientists or reagent partners, to run on your robot. And we'll show you how to alter key parameters such as sample number from run to run. And then finally, we'll answer any questions you may have at the end of the demo. So I'm just going to pause here for a minute just to make sure everyone is signed up and comfortable. And I'll use this time to just plug our demo room, which is where this webinar is taking place. So this demo room is in our headquarters, which is in Long Island City, New York. And if you or anyone from your team are in the area, either visiting or if you live here, then please feel free to work with your main point of contact at Opentrons to schedule a visit. We'd love to see you here. You can check out our office and meet the team, and of course, see the Opentrons Flex in person. Okay, so I think we might be good to go now. So just a quick reminder before we start that this webinar is being recorded and it will be made available on the Opentrons website after we finished. And we'll also send a copy of the recording via email after the webinar. So to help with everyone's experience, everyone's on mute. To ask a question, you can use the Q&A box at the bottom of your screen, and we'll answer your questions at the end of the talk. Okay. So before we get started talking about the robot, I wanted to say a few things about Opentrons ethos and why we exist. So it's our mission to support scientists doing groundbreaking, valuable research with powerful, accessible lab automation. And our aim is to really free you to do more than pipette and be able to focus on science. We've helped thousands of labs across the world automate their workflows. And with the Opentrons Flex, which is our newest generation robot, we're excited to show you how it can help you and your lab increase your throughput and automate your workflows. Okay, so jumping in to talk about the Flex itself, I'm going to show you a few key features on the Flex, and then Nick is going to run through a short demo about finding and configuring a pre-existing protocol from the library, and then running it, and then we'll take questions, as I mentioned. But you can type in your questions at any point, so from now on. So our software engineer, Nick Deal, is monitoring the Q&A box while we talk, so feel free to ask questions at any point. Okay, so this is the Flex. And as you can see, the thing that just moved to the front is the gantry. The gantry holds 1 or 2 pipettes. Here we have 2 pipettes, a single and an 8-channel, and then also a gripper on the right-hand side next to the pipettes. So the pipettes, as I mentioned, we have a single and an 8-channel here. Both the single and the 8-channel come in 2 volume configurations. So the P50, which covers 1 to 50 microliters, and the P1000, which covers 5 to 1,000 microliters. The 96-channel pipette, which you don't see actually on this robot, comes in 1 size, and that's 5 to 1,000. With the 96 channel, you can obviously pipette 96 samples all at once, but you can also do something called partial tip pickup, which allows the 96 channel to pick up either 1 tip, 1 row of tips, 1 column of tips, and in the future, several rows of columns. So in that regard, you can really use the 96 to provide a whole bunch of different ways to kind of pipette things around the deck. One thing to note is you can hold any combination of single and 8s on the gantry. So you can have 2 singles, 2 multis, or as we have here, a single and a multi next to each other. Or you can have the 96 channel on its own, just because it takes up sort of the whole space here. And as I mentioned, we've got the gripper on the right-hand side or left-hand side, depending on how you're looking at it, of the pipettes, which can move tip racks and plates across the deck and into the trash bin at the back. We also have a trash chute available, which you can't see on this robot because it sort of takes up a lot of space. It attaches to the front here and allows you to put your waste into an external bin, which sort of really supports higher throughput workflows and kind of extending the walkaway time that you can achieve with a benchtop robot. Okay, so moving down to the deck. So the deck has 12 standard slots here, where you can put tips, labware, modules, and so on. There are also 4 extension deck slots. You can actually see 2 of them here to the right of the main deck. And these can be used to hold extra tips and labware. The gripper can access the 12 standard deck slots. It can also access the extension slots on the right, allowing you to bring in additional labware and tips onto the main deck so that the pipettes can access them. It's kind of an important thing to note that the modules here are all flexible. You can move them around. We'll just talk through what's on the deck right now. First of all, we have a magnetic block here in the middle. It's a standard 96 well magnet plate. Over here, we have a heater shaker, which can shake from 200 to 3000 RPM and heat to 95 degrees C. Behind it, a temperature module, which can go from 4 to 95 degrees C. And at the back, you can kind of just see the lid here is the Opentrons thermocycler, which can automatically open and close using the software. And so it's a really kind of unique option for automating kind of PCR and other workflows. And finally, I mentioned at the beginning, we just recently launched this HEPA UV accessory that sits neatly on top of the robot and allows you to sterilize the deck surface and also filter contaminants from the working area. And as I mentioned before, all of this is completely modular. So you're not tied to this robot doing one thing forever. You can easily swap out pipettes, modules, and so on to change the application that you're using it for or to increase your throughput. One final thing that I just wanted to mention is this on-deck touchscreen, which allows you to easily store and pull up and then run protocols. It also guides you through deck setup, and Nick will talk you through that in a minute, and an automated calibration. And kind of most importantly, it's really here to provide you with a lot of prompts and guidance. So it really makes the steps that you go through before the robot starts to run really straightforward and easy to follow. And that should be for anyone in the lab to carry out experiments on this robot, whether they're really experienced with automation and Opentrons products or not experienced with automation at all. And finally, I just wanted to talk about our service offerings. So we offer a white glove approach to service for our users. So that includes on-site installation of the robot, training for your team, all from one of our specialized field application scientists. They also provide you with kind of on-site support, quick turnaround time, ongoing preventative maintenance, and IQ/OQ. So we have both field application scientists to really act as your technical and application automation consultants, as well as field application engineers who are more focused on the ongoing support and PMs for your robot. And if you want to know more about services, please talk to your local territory manager, and they will be able to discuss kind of what kind of service and support offerings are best for you and your lab. Okay, and with that, I'm going to pass the mic over to Nick, who will run through finding and configuring a protocol in the library and then running it on the Flex.
Thank you so much, Fran. Hi, everybody. Hope everyone's day is going well. I'm just resetting the robot here as we get prepped for the demo. First, I want to give an overview of the different ways that you can create protocols for your workflows on the Flex. As Fran mentioned, an FAS from Opentrons team can actually provide on-site application development and optimization. It's great to have them working there with you. We do also offer remote protocol development and optimization. And you do also have the option to write protocols yourself, either through our Python API or through one of our UI-driven tools, such as Protocol Designer. And finally, the option that I'm going to talk about today is how to download a pre-existing protocol from our open access protocol library, which is a repository of pre-designed protocols, which cover a wide range of applications, from DNA extractions to PCR setups. And I'm going to walk you through the process of finding and then downloading and then finally uploading a protocol, which is going to fit your needs and hopefully fit the workflows. First, we will need to navigate to the protocol library. You can do this through our website, and there you can browse the extensive collection of protocols. Opentrons really is trying to simplify the complexity of these procedures and ensure accuracy and reproducibility for your lab space and the other lab spaces that we are reaching. Additionally, we have a number of verified protocols that our in-house science team or the relevant kit manufacturers have tested, which are then going to be given to you. To find the protocol that fits our needs, we can search, or we have a pretty extensive filtering tool set, which is going to allow us to browse based on a category such as application. Today, I'm going to be showing you a trypsin-based digestion, and there's going to be kind of several ones that are going to pop up, and I'll show you also how to kind of filter through those to kind of find the one that's best going to fit your needs and the kind of relevant robot information that you'll have up. So the first thing I'm going to do here is I'm actually going to share my screen, and we're going to navigate over to the Opentrons website. So I hope everyone can see my screen now. So here you'll have the basic web page. You have several features that we have, as I talked about, the protocol designer, which is one of our other kind of UI-based protocol creation or authorship tools. We have extensive Python API documentation, as well as a labware library and our GitHub repo. Here I'm going to click on the protocol library tab. We do have some pinned tabs or some pinned protocols, which are kind of the most relevant currently, or kind of maybe they're newer that we just debuted. As I said before, I'm now going to search for trypsin. And there's going to be about 5 results that pop up here. I know that I'm going to be looking for one that's on the Flex. So just scrolling down to these robot models here, I'm going to find one that's for the Flex. And then I'm also going to find one that has custom parameters designed for every run here. So instead of just having these protocol parameters pop up at the download, we now have feature sets written into the Python command set that allow you to modify parameters either from the app or on the touch screen every run. So it really creates a very kind of flexible and robust protocol from one space. So clicking into this, I can start to see kind of more of the meat of what these protocols are actually going to be able to accomplish. Over on the left-hand side here, I have kind of a human readable format for everything that is going to occur in this protocol. As you go through this, it'll kind of discuss, what reagents are there, what are they actually doing, what is the end result of this going to be. Over on the right-hand side, I have what the kind of relevant deck setup is. As I scroll down, I can see kind of a more detailed view of this deck setup. You can start to see a little bit more of what modules are required, and these are also called out over here on the left-hand side. All of the relevant labwares will also be called out. Clicking into any of these, you can pop up what exact labware this is, and you can also shop for them. The same kind of behavior also holds true for the modules and also the pipettes that we will be using here. A quick note is that specifically with these editable protocols, you can download them and change some features such as the pipettes that are necessary. Here we already have the robot configured for the correct setup, so it's going to be kind of a one-to-one kind of comparison here. But you do always have the ability to modify those. We do also have another product offering in terms of a protocol amendment, in which our FAS team will also come either on-site or remotely and modify a protocol that is already in existence. But hopefully the protocol library is going to get you very close to being able to get up and running immediately. As I scroll further down, we also have some further kind of examples of what this protocol is actually going to perform. These are definitely abstractions. The protocol itself, as I mentioned, is written out in Python steps. So all of these, protocol steps here are going to be written out kind of in much more robust kind of coded language, but this is the general idea. And we will also have these tables, which make more sense as I scroll all the way to the bottom to discuss what the runtime parameters of interest are here. A very popular runtime parameter is going to be number of samples. So here the default number of samples is going to be 96. As you can see, we can drop this all the way down to 1. We also have what labware is going to hold our samples, so we can select what tube type. We have how long of a digestion period are we going to have for the trypsin, and also in which position on the left or the right mount is our one channel pipette. So if I scroll back up, these tables make a little bit more sense now in terms of what amount of reagent do we need to have in each of the columns for the relevant number of samples here. As you can see, the sample count here is broken out by the individual columns. So it goes from 8, 16, 24. And the same is true up here for the other labwares that are necessary. Scrolling back down, we do also have some reference publications, which you can click into to kind of gain a deeper understanding of the science that is being supported here. And if I scroll all the way back up, I can go ahead and actually download this protocol. So once that has been downloaded, I can navigate over to my Opentrons app, which I already have open here. If you have protocols downloaded previously, this screen will show those. Instead, though, I can just click that I'm going to upload a protocol here. If I scroll down past all of my blanks and open this protocol, it's going to perform an apt analysis of this. So this is going to now kind of be in a verified state. I can always reanalyze this or start the setup here. I also have the option to send this to an Opentrons Flex. As you can see, we do have several that are available to us, which makes sense as we are at Opentrons HQ here. If I scroll back over, I also have the ability to look at the current settings that are relevant to this instrument that is sitting behind me. This is just a kind of a screen share of what is happening on the touch screen here. And so the touch screen has a ton of relevant information that will help you out as you get things moving. Here you can see what the robot name is. If I clicked into network settings, I could see things such as IP address and other features that are going to be helpful. But if I know that this is going to be on freezer, I can click that I'm going to be performing all of this on the freezer and send this over. So now if I look at all of the protocols that are on this instrument, I can see that I have trypsin digestion. And this is also going to pull up information that is very similar to what was shown on the library or on the protocol library downloads page. I don't know if you can see it over in the corner there, but this is also populating directly onto the touchscreen on the robot next to me. So you can see the summary. You can either pin or unpin a protocol, which is basically going to bring it to the front as you run it. You can see what the parameters are and what their default values are. You can see the relevant hardware and what is currently mounted. If there are any discrepancies between the hardware that is actually mounted on the instrument and the one that is necessary to run the protocol, those are going to show up here. And you will have to resolve those before you can actually start the setup. It will show you what the relevant labware is, as well as the relevant quantities of them. All of the liquids which have been created in the protocol are highlighted here as well. These are going to be based off of some of the relevant runtime parameters. And lastly, you can see what the deck is and how it is set up. This is also based off of some of the relevant parameters. I have changed the defaults here to actually utilize a much smaller subset of samples. In the previous one, it was actually kind of using all of these locations. But now I can go ahead and I can say start the setup here. The first thing that it's going to do is ask me to fill in any of the runtime parameters that are necessary. So I can go ahead and specify that instead of 1, I'm just going to run, or 8, I'm just going to run 1 sample here for the sake of time. I can specify the tubes and the digestion period. Again, I'm going to make that kind of as short as possible just for demo's sake. Once I confirm these values, it's just going to check to make sure that they haven't broken anything. And then all of these other ones, if there were anything that is lacking or any kind of hardware differences, these would actually pop up as yellow and you would have to adjust them. Instead, now I have the ability to run this protocol. I can actually stop the share here so that it will pop back up into the robot view. And I can go ahead and click run on this. The first thing that this is going to ask me to do is it's actually going to open the thermocycler lid first, and then it will ask me to put on a plate, which is going to house our reagents, as these will typically be kept on ice before you want to put them onto the deck. And so this is another great example of how helpful the touchscreen is, so that you can be keeping your reagents somewhere else, refrigerated. You could even not have them prepared until this screen pops up and the protocol will pause for you. And then without interacting with your computer whatsoever, you can confirm and resume. As you can also maybe tell, there are just kind of short descriptions of each step that are going to populate in. This is another really helpful feature of protocols that have been downloaded from the protocol library, is that these are kind of written out in the Python script as kind of commented out lines. And so it's really kind of very nice to see what these relevant steps look like in kind of a robustly designed protocol. As you saw in the tables, this protocol is designed for kind of column-based work. For demo purposes, I just shorten it to only do one sample, but we are still going to use the 8-channel pipette here to take all of these reagents in order to do this kind of quickly. So these will be deposited into the plate that's on the thermocycler. Because the plate is already on the thermocycler for this as well, which is like kind of a really nifty trick to save time and also save deck space, we will not need to have any kind of gripper interaction. If the plate were to need other steps, such as magnetic heat cleanup, the plate would obviously have to start in a different location, and then the on-deck gripper can really shine. Here we will add 2 relevant reagents, ABC and DPT, to the sample count here. And then once these have been completed, again, for the sake of demo, we are going to skip the 2 subsequent incubation steps, where further reagent would be added, and then fixing would also be added, and we can select how long of an incubation period we want. So instead, once this lid reaches the set temperature that is relevant for it, the thermocycler will close automatically, and we can pause the protocol afterwards. So as soon as this is closed and locked, we can go ahead and pause